Ladies and gentlemen, boys and girls, children of all ages, welcome back to another video. We are still in grade 7 and hopefully today we'll be able to understand a bit better the concept of bounds. Right? If you have any questions about the specific topic or any questions about any other topic with regards to maths, please do leave it in the comment section below and I'll hopefully be able to get to those questions as soon as possible. Okay, so the question we're doing today is a bit of a different one. It's the hardest one I could find. It is a bit different compared to other questions on bounds, but hopefully we'll be able to use our current knowledge on bounds to figure out what's going on here. The question is as follows. V squared equals U squared plus 2AS. V is equal to 35.2 corrected to 1 decimal place. A is equal to 9.8 correct to 1 decimal place. And S is equal to 60.35 correct to 2 decimal places. Now it says work out the upper bound for U, giving our answer to 3 significant figures. So the only part I'm actually going to highlight for this question, we are trying to figure out the upper bound of U, and we're leaving answers to 3 significant figures. Obviously everything else is already important, all the values that we need to use, but there's no point in highlighting the whole question. And for those of you who don't know, V squared equals U squared plus 2AS is a very, very important equation when it comes to mechanics. When it comes to distance time graphs or speed, so on and so forth. But you'll find out more about that in A-level if you choose to do maths at A-level. So it's quite nice how they used an equation that actually matters as an example for upper and lower bound, which is quite nice. Okay, so where do we start off? Well, we are given 3 values, V, A, and S. So what I'm going to do first is I'm going to write down the upper and lower bounds for those values. And that is just to know what values I'm allowed to use. So for V, it is correct to 1 decimal place, which means that it has to be less than 35.25. Because if it was 35.25, that would make it round up to 35.3. And its lower bound would be 35.15. And it could be equal to that, because if it was equal to 35.15, then you would automatically be able to round up to 35.2. The next number is our acceleration, which is 9.8. It's correct to 1 decimal place, which means our acceleration, the maximum value to 1 decimal place, can be 9.85. And our lowest value can be, our lower bound can be 9.75. Okay, and finally, we have our S. Now, S does not stand for speed, it stands for displacement, just so you guys are aware. V is final velocity, A is acceleration, S is displacement, and U is initial velocity. And now this is corrected 2 decimal places. Again, we have to look at what it's telling us it's rounded up to. So that would be 60.355. And its lower bound would be 60.345. All right, now that we have all of our bounds for our values, we're trying to work out the upper bound for U. Now, to work out the upper bound for U, what we need to do is rearrange the equation so that we have U on its own, so we know how to find out an upper value for U. So our upper value for U will happen, firstly, when we rearrange it to give us V squared minus 2AS, which is equal to U squared. And we have to square root it, so that would give us square root of V squared minus 2AS is equal to U. Now the biggest value that our U can take is when everything inside the square root is as big as it can be. But that does not mean we would have the maximum value of V squared and the maximum value of 2AS. Because we are doing subtraction, the way to get this to be the biggest value possible, we would need V squared to be as big as possible and the 2AS to be as small as possible. Because a big number minus a small number will give you a bigger number than having 2 big numbers subtracting from each other. So for example, I can actually show you this very quickly. If we have 6 minus 5, those are very big values. But if I had 6 minus 2, this would be equal to 4, this would be equal to 1. So even though both of these, 6 and 5, are big values, it gives us a difference of 1, whereas a big value minus a small value gives us a bigger number, and that's what we want in this square root, because the square root of a bigger number will give us the biggest value we can possibly have. All right, so what we're trying to do is we're trying to maximize v squared and we're trying to minimize 2as. Let's see how we can do that. So using these values that we have, I'm just going to rewrite the square root of v squared minus 2as. So firstly, we're going to maximize our v squared, and to do that, we're going to pick the upper bound of v, which is 35.25. 35.25, and all of that is being squared. Then we have minus 2, so we can't minimize the 2 because the 2 is a constant. We have 2 multiplied by our acceleration. Now we're trying to get a very, very small number, so we're going to have to use the smallest number possible, which is 9.75 for the acceleration, and 60.345 for the displacement. And the reason for this, again, is if we chose 9.85, then 9.85 multiplied by this would give us a bigger number than 9.75 multiplied by 60.345. And the same reason for why we didn't use 60.355. We can get an answer to this by plugging our values into the calculator, and that would give us 65.835. And what we're actually trying to do is we're trying to square root it. So if we do the square root of 65.835, we should get 8.1138770002, and obviously it keeps on going on forever and ever. However, the question, if we go back to the actual question, it says, work out the upper bound for u, give your answers to 3 significant figures. All right. So this is the upper bound for u. This right here is the upper bound for u, but we have to give it to 3 significant figures, which would be equal to 8.11. So those are the 3 significant figures, and that would be our answer. So our answer would be 8.11. This was a bit of a longer method, and it required you to actually understand what the question was asking, but let's go over it again so we can make sure that we understand what was going on. So the question gave us an equation. It gave us 3 of the values which are correct to 1 decimal place or to 2 decimal place, and the question was asking us to work out the upper bound for u. And we have to give our answers to 3 significant figures. So what I did first was I found out the upper and lower bounds of all my values, just to show which numbers I was allowed to use in this question. The next thing I did was I rearranged the formula to give u on its own so we could find out u, and u was equal to the square root of v squared minus 2as. And I knew to make u the biggest number possible, or to find the upper bound, I would have to maximize v squared and minimize 2as. And that's what I did over here. So I got the maximum value of v squared from getting the upper bound of v, then getting the lower bounds of a and s, working that out to be 65.835, and then square rooting it to get 8.11 to 3 significant figures. Now just to quickly show you guys how to find the lower bound in case you had to do that, we would have to do the opposite of what we just did. So instead of maximizing v squared and minimizing the 2as, we'd have to maximize the 2as and minimize the v squared, so that our number inside the square root would be quite small, so we would end up getting the smallest value possible. All right, so just to show you guys how that would work, if I go down here, if we're trying to find the minimum or the lower bound, lower bound. To do that, we are still doing the square root of v squared minus 2as, but this time our v squared will be 35.15 squared, and we are doing minus 2 times the maximum values we can get, 9.85 and 60.355. And if we did that, you put that into your calculator and you should get 6.8212169, which to three significant figures would be 6.82. Don't forget your brackets. If you don't put that in the calculator, it might give you the wrong answer. So there we have it. We have 6.82, which means that our value for u, so we've got our three bounds here, so I can actually put u here. We can say the maximum would be 8.11. All of this is to three significant figures. And our lowest would be 6.82. This is our lower bound. So I hope this question has made sense. I tried to go into as much detail as I possibly could, because this is one of those questions which is quite difficult for a lot of people to understand what's actually going on. But once you read the question and you think about it, I think it makes it quite easy to actually know what the question is trying to ask of you. So I hope you enjoyed this question. If you have any other questions with regards to this specific topic, please leave it in the comment section below, and I hope to get to you as soon as possible. All right, stay safe.